Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Intermolecular hydrogen bonding requires a hydrogen atom bonded to a highly electronegative atom, F, O, or N, and a lone pair on an electronegative atom of a neighboring molecule. The strength of hydrogen bonding depends on the electronegativity and the partial positive charge on the H atom, which is influenced by the acidity electron withdrawing character of the group attached to O or N. Moving on to the next step. Formaldehyde, HCHO, has a carbonyl group but no OH or NH bond, so it cannot act as a hydrogen bond donor. It cannot form intermolecular hydrogen bonds with itself. Moving on to the next step. Compare the remaining candidates that have OH or NH bonds. Methylamine, CH3NH2 has NH bonds. N is less electronegative than O, so NH hydrogen bonds are weaker than OH hydrogen bonds. Methanol, CH3O has an OH bond. The methyl group is electron donating, which slightly reduces the partial positive charge on H. Phenol, C6H5O has an OH bond. The phenyl ring is electron withdrawing through resonance. The lone pair on O delocalizes into the ring, which increases the partial positive charge on the OH hydrogen and makes phenol more acidic than methanol, pK-10 versus 15.5. A more acidic OH means the H is more positively polarized, leading to stronger hydrogen bonding. And for the final step. Among all four options, phenol forms the strongest intermolecular hydrogen bonds because the aromatic ring withdraws electron density from oxygen via resonance, enhancing the delta plus on H and strengthening the OH O hydrogen bond compared to methanol or methylamine. Therefore, the correct answer is B. Therefore, the correct answer is option B.